Hey guys, right after watching this video, you might feel so much confident not to design any more slabs using STAAD Pro. Alright, I'll be dividing this video right into three particular segments. The first case, in the case 1, I'll be providing a plate on top of here and no meshing. And in the second case, I'll be providing a plate right here, but I'll be meshing this. Plate is there but with meshing. And right in the third case, no plate. Rather than creating a slab, I will be providing floor loads right on top of here. This one will be floor loads. Okay, so let's simulate these three cases in STAAD Pro. So right in here, take a new structure. Yeah, let's do this. Okay, in the first case, I'll be adding a grid, okay, right onto the exit plane. I'll try to keep it a two-way slab, right? Then right in select, I want to convert this into a column. So right, I'll be picking the translate repeat, and right in the y direction the spacing will be maybe -3. Okay, so we got the column and beam. And what I'm gonna do now is I'll be selecting upon all the top and I'll be infilling these plates here. So you can see that right now we got the structure 1 is complete. Okay, you can see that structure 1 is complete. Now let's see what's happening in the structure 2. So by getting into the geometry, I'll be selecting all of the geometry and I'll be translating this right maybe 7 meters and into the X direction. Okay, so now we got two slabs here. Right in the second case, the slab is being meshed. So in order to mesh it, I'll be selecting the plate cursor and generate plate map. Really doesn't matter whether it's polygon or quadrilateral. Okay, so these are the assets here. Now it's a usual case, you can assign materials. So right in here I'll be assigning a concrete section 0.6 and maybe 0.3. okay, then we are going for a slab. The thickness of the slab is maybe 0.12. and I'll be assigning everything right into view. So assign this into view and plate assign it to view. Okay, now let's care on supports. So I'll be selecting the base nodes and I'm gonna get into support, fix support, and assign the support right into the select nodes. Alright, that looks great. Now let's add some loading right here. So maybe I will be picking I'm not really interested in creating combination. This video is not for that. Okay, if you have drawn plate, what you want to do here is you want to pick up the self weight. Then you have to set. Now we want to go to the plate load, maybe -3 kilonewton per meter square to the gravity direction, and assign both of these assets right into view. So assign this to view and assign the plate load right into view. Alright, that's enough for now. Let me get into analysis. So probably I don't want to take out any print and I'll be running the analysis. Alright, gonna get into post-processing mode. Now the first thing that you wanna hear is if you check the displacement, you can see that if the plate is meshed, you can see the displacement. If the plate is not meshed, you might not see any displacement. The second thing that you wanna care is the plate stress here. So maybe if I can get into maximum absolute, you can see that if the plate is meshed, you can see that the distribution of a proper shear stress will be seen right onto the slabs. Okay, that's the two advantages of meshing this figure. Now let's see the main villain. If I get into the design section, maybe I can pick up the concrete, which is right here, and I'll be picking up the concrete code, which is based on Indian one. I can select the parameter. I'm not really interested in selecting all the tons of parameters, but here I'll be selecting only the concrete grade. Now to define the parameters, that is can be like M25, so I'm adding 25,000 here. Okay, assigning this right into view, assign it to view. Okay, now the important thing in comments is I'll be designing beam. Okay, I'll be designing, no, I don't want to design column. I'll be designing the plate. Okay, now in order to select the beams, I'm gonna get into select and I'll be picking the beams parallel to X and Z. So now let's select the beam here. So okay, so select the beams parallel to X and Z, and well, assigned to selected beams, so that's okay. Now design of element, I'll be assigning this right into view. Alright, now let's get into run analysis, and well, I want to view the output file. Before viewing the output file, you know that this is plate number 1 and this is plate number 2, so there are only literally 2 plates right in our structure. But we've got a tons of warning here, so you can see that. Let's get into warning in a moment. Structure is disjoint. Okay, there is a warning. You can see that the first member is having the length of 3 meters, which is totally okay. Now the second member, the length is again 3 meters, okay. Third member 1 meter, and fourth member is 1 meter. Okay, so I think probably these are the 4 sections here. Now let's see the main asset here. So for the next member, the length of the beam is 300. Absolutely, that's not how the length of the beam will be. So that will be 300 millimeter, and so that's why these warnings are there. Probably a span or the length will be much greater than all of the other dimensions, but for this particular structure, right, as you can see that for this particular structure, okay, maybe you can see that this is B and this is D and this is L, so obviously length shall be greater than B or D. Okay, but here the length to depth ratio is less than 2.5, so probably this beam won't be designing. But we never saw that case right in here. We never saw that warning right in this case. Why? Because the plate is not meshed. If the plate is meshed, right in the second figure, if the plate is being meshed, the nearby beams will also get divided so as to transfer the load from the slab to beam. So if the plate is meshed, you can see that the stress distribution is proper and the deflection is also proper. But if the case of design is being concerned, the design is not totally alright. Okay, so that's the problem, if you can understand right in STAAD Pro. If you scroll up a bit to down, let's see what happened in the case of design of slab. So maybe I think it's over here. Yeah, this is over here. Okay, you can see that the member number is 9 and the top reinforcement is 120. Okay, this number will never change. This will be 120 itself. But you can see that there are total of
100, 134, 160, 200, 200 slabs, 200 slabs. So let me use the paste down button. There are total of
394 plates. But actually the number is supposed to be, 2. So that 2, the first one is not splitted, but the second one has been splitted right into 100 segments. So that case is seen right here. If I turn Shift N or maybe Shift P to turn up the plate numbers, I can see that there are a total of plate layout. Getting the plate layout, there are a total of 394 plates are there. So that's not how this is supposed to work. You're not going to design a Milky Bar type of slab in STAAD Pro, okay? So I'm gonna ask you not to draw any sort of plate in STAAD Pro. Rather, what we gonna do here is, so get into the geometry cursor, and I'm gonna delete this part, Okay, now you select the plate, and I'm gonna delete this plate. This should be the actual procedure. Now, rather than providing a slab on top of here by drawing beam, we just want to understand the height of the structure. So getting to node to node distance, and now pick up these 2 points together, so that would be 3 meters. So just delete the plate, and what you might gonna do here is get into floor load and assign the value. Okay, this will be the plate load actual case, and there's an option for Y range, so you can type maybe 3 meters right on here. The main advantage of the slab is you don't want to assign the slab section right into this, so that is the first case. Now there's one more case here to provide a slab load, so you might want to select all these beams, and you can get into group by hitting Ctrl G, and I'm gonna give him a name, whatever be the name, and right in here I might want to pick up floor, and I have to associate it, just that. Now after you get into load case details, right in floor load, you can see group options right here, and the simple thing, and what you can really do from here is you might want to give the value of load here and add it, so you can say that here. Okay, this method never designed a slab, as I have never drawn any type of slab right on top of here. Rather than providing a slab, a physical slab on top of here, we will be providing the slab load as you can see that this is uniformly varying load right in here. Okay, so based on that, the beams and columns will be designed, but not your slab. Okay, so usually we'll be picking the third method, and we'll be totally avoiding the first and second method, as that will never give any proper design. So well, that's it in this video. If anyone's watching, thanks for watching.